Serverless architecture is changing the way developers build applications. Instead of managing servers, developers can now focus on writing code while the cloud provider takes care of the infrastructure. This means no more worrying about provisioning, configuring, or scaling servers. Serverless allows you to deploy functions that run in response to events like HTTP requests or database changes. The result: faster development, automatic scaling, and less operational hassle. In this video, we'll explore how serverless fits into full-stack development and why it's becoming the go-to choice for modern apps. Traditional server-based development, you're responsible for managing the entire stack. This includes provisioning servers, setting up operating systems, and handling scaling as your app grows. With serverless, all of that is abstracted away. The cloud provider manages the infrastructure so you can focus on building features. This shift not only saves time but also reduces costs and operational complexity. Let's see how this difference impacts the way full-stack applications are built and maintained. The heart of serverless is function as a service, or FaaS. With FaaS, you write small stateless functions that execute in response to specific events. Popular platforms like AWS Lambda, Azure Functions, and Google Cloud Functions make it easy to deploy these functions. Each function runs independently and scales automatically based on demand. This approach lets you break your application into microservices, making it more modular and easier to maintain. Serverless architecture often relies on backend as a service, or BaaS, to handle common backend tasks. Services like authentication, databases, file storage, and messaging are managed by providers such as Firebase, Auth0, and Amazon DynamoDB. This means you don't have to build these features from scratch. Instead, you integrate with these services, speeding up development and ensuring reliability. BaaS is a key component in building scalable, secure, and efficient full-stack applications. Serverless applications are typically event-driven. This means your code runs in response to events like HTTP requests, file uploads, or messages in a queue. The event-driven model allows different parts of your application to communicate asynchronously, making your system more scalable and resilient. By decoupling components, you can build systems that are easier to update and maintain, and that can handle spikes in traffic without manual intervention. One of the biggest advantages of serverless is managed infrastructure. The cloud provider takes care of provisioning, scaling, and maintaining servers. You simply define your functions and services, and the provider ensures they run smoothly. This eliminates the need for dedicated operations teams and reduces the risk of downtime. Developers can focus on building features, knowing that the underlying infrastructure is reliable and secure. Serverless architecture is cost-efficient thanks to its pay-as-you-go model. You only pay for the compute time your functions actually use, rather than paying for idle server time. There are no upfront costs or the need to over-provision resources to handle traffic spikes. This makes serverless especially attractive for startups and projects with unpredictable workloads, as you can scale up or down automatically without worrying about wasted resources. Serverless scalability is built in. If your application experiences a sudden surge in traffic, the platform automatically provisions more resources to handle the load. There's no need to manually adjust server capacity or worry about downtime. This ensures your app remains responsive and available, even during unexpected spikes. Automatic scalability is a game changer for modern web and mobile applications. Serverless lets developers focus on what matters most, writing application code. By abstracting away infrastructure management, developers can spend more time building features and less time troubleshooting servers. This leads to faster development cycles, increased productivity, and more innovation. Serverless empowers teams to deliver value to users quickly and efficiently. With serverless, operational overhead is greatly reduced. The cloud provider handles patching, updates, and server maintenance. There's no need for dedicated DevOps resources or complex deployment pipelines. This simplification allows teams to focus on delivering features and improving user experience rather than managing infrastructure. The result is a leaner, more agile development process. Despite its advantages, serverless comes with challenges. One common issue is the cold start. When a function hasn't been used for a while, it can take a few moments for the cloud provider to spin up the necessary resources. This delay can impact applications that require instant responses. While providers are working to minimize cold starts, it's important to consider this when designing latency-sensitive systems. Serverless functions are stateless, meaning they don't retain data between invocations. For applications that need to store and retrieve data, you must rely on external services like databases or storage solutions. Managing state in a serverless environment requires careful planning and integration with persistent data stores. This adds complexity, but also encourages best practices in data management and security. Debugging serverless applications can be more complex, especially when your logic is distributed across multiple functions and services. Tracing requests and monitoring logs may require new tools and approaches. Another challenge is vendor lock-in. Relying on a specific cloud provider's platform can make it difficult to migrate your app elsewhere. Using frameworks like Serverless Framework or AWS SAM can help reduce this risk by abstracting provider-specific detail. Serverless fits perfectly into full-stack development. On the front end, you can use frameworks like React, Angular, or Vue.js, communicating with serverless backend functions via REST-TFL or GraphQL APIs. The backend is composed of small, focused functions that handle business logic, authentication, and data processing. Cloud databases like DynamoDB or Firestore provide persistence, while authentication is managed by services like Auth0 or Firebase authentication. This architecture is highly scalable, secure, and cost-effective. Typical serverless full-stack architecture includes a front-end app, like React, hosted on Vercel or Netlify, communicating with serverless functions via an API gateway. These functions handle tasks such as authentication, data processing, and file uploads. Data is stored in scalable NoSQL databases like DynamoDB or Firestore, while authentication is managed by services like Auth0 or Firebase authentication. This setup allows for rapid development, easy scaling, and secure access control. Several frameworks make it easier to build serverless full-stack applications. The serverless framework lets you define and deploy functions using simple configuration files. AWS SAM is tailored for building serverless apps on AWS. Firebase provides a complete BOS solution with functions, databases, and authentication. Netlify functions allow you to deploy serverless logic alongside your static frontend. These tools streamline development and help you get your app to market faster. Serverless architecture is transforming full-stack development. By abstracting away infrastructure, enabling automatic scaling, and reducing costs, serverless empowers developers to build modern, scalable, and efficient applications. While there are challenges like cold starts and vendor lock-in, the benefits far outweigh the drawbacks for many use cases. As cloud technology evolves, serverless will continue to play a central role in the future of web and mobile development.